Well, hello everyone. We're happy to see y'all here, and we're excited to go over some strategies for preparing for the NJSLA science test. And if you don't use InnerOrbit, this can also be helpful for you, how you could actually introduce this and make your whole year actually not just test prep in the last few days before the test, but actually how you can introduce strategies for throughout your instruction throughout the whole year. And to start, we're actually going to introduce ourselves. Emily?
All right. So my name is Emily Miller. My pronouns are she, her. I was a high school chemistry teacher for 10 years. And when I was doing that, I had the opportunity to teach in our alternative learning program. I taught regular chem and honors chem. So I had a lot of opportunities to try a lot of different strategies. I was an NGSS pioneer and advocate in my science department. And I was also a PLC lead for data-driven dialogue and data chats because I love data and I love talking about it. And now I have the pleasure of partnering with districts to help them implement InnerOrbit. So I work with the central time zone over to the west. And if I had to pick, I would eat savory food over sweet food. And this is not to say I'm like anti-chocolate or anything, but like if I go to a restaurant, I'm ordering an appetizer instead of a dessert. Like let's like carbs and cheese and delicious things first and second is like my ideal situation. Julia, if you want to go ahead and introduce yourself.
Yeah, I don't know if I agree with the appetizer part of that. I would very much rather not eat a large lunch just so I can have some sweet treats after. But my name is Julia. My pronouns are also she, her. And I was a teacher and a tutor for elementary students in the Dominican Republic for a few years. And I've been supporting teachers and districts with their NGSS implementation for the past 3 years now. I am InnerOrbit's district engagement manager for the East Coast and Eastern time zone. So I have the pleasure to partner and provide guidance for schools and districts implementing assessment in their NGSS instruction. And I think that matcha is better than coffee. So just because it doesn't give you those coffee jitters. So I really like matcha. Now on to our agenda for today. Emily, do you want to walk us through it?
I'd be happy to. So, our objective for today is we're going to analyze some release test items and dive into some resources and strategies to help practice and prepare for the New Jersey Student Learning Assessment for Science. We're going to be here for about 30 minutes today. And today we are going to first look at some release test item examples, and we're going to analyze them a little bit, specifically looking at the performance expectation tied to it and then the three dimensions of that. Then we're going to talk about how we can practice sense making actually in our classrooms by using phenomena throughout a unit, scaffolding back a grade level, and then we're going to talk about how we can actually scaffold students up to answer three-dimensional questions like they're going to see on the NJSLA-S test. We're going to look at some InnerOrbit items, but with that, let's go ahead and dive in and get started. So before we actually get into the content of what we're talking about, we just wanted to quick introduce InnerOrbit and what it is, just in case you were unfamiliar with who we are and what we do. So InnerOrbit is essentially four things, the first of which is novel phenomena. So on our website, we have over 1,000 novel phenomena that our questions are tied to. And this gives students a chance to really practice sense making, trying to use what they've already learned in the sense of something new and novel. Like I mentioned, we also are questions. So with that 1,000 phenomena, we have over 10,000 different assessment items that are all aligned to the NGSS. And what I think we do a really good job is we actually scaffold students up to answer those three-dimensional questions, which Julia is going to talk about in this webinar today. The third thing we are is data. So we have some really cool detailed reports on our site where you can look and actually see how students are doing on the three different dimensions. So for example, you could see how students are doing on the SCP developing and using models, and specifically what elements of that SCP students are maybe doing well with or need more support with. And then the last thing that InnerOrbit is professional development. So we use research and context-based strategies. We like to go into classrooms or do things virtually. We are constantly changing what we do based on the feedback we get from our teachers. And we like being able to share, like we are in this webinar, ways that we can help support science educators with the NGSS. If you are interested at all about learning about InnerOrbit or potentially piloting InnerOrbit in your schools, Julia just dropped in the chat a link that you can use to actually schedule a meeting with her, and she would be happy to talk to you about what that could potentially look like. So, on to the meat of today. Let's start by identifying sense making. So, what that is and what it looks like in questions. So, what I have right here is a released assessment item from the NJSLA-S. It always takes me a minute to say that one. And this is actually a chemistry question. So if you look at this, we have students investigating why some parts of a bicycle have rusted, and they're trying to figure out if iron and rust are the same substance or not. So they performed an investigation where they put rust and iron into different test tubes under different conditions. They collected some data, and they've got some characteristics of iron and rust in that table as well. So the question I would like to ask all of you, and I would love if you would answer in the chat, is, do you think in this question, students are applying their understanding of chemical reactions? So yes, in fact, students are. And this might look a little bit different than what you would maybe expect for a question to look like to have students represent what they know about chemical reactions. And this is kind of the point that we're trying to make. So we're going to talk a little bit about the difference between sense making versus representation. So representation is great for students to communicate ideas that they've previously learned. So this would be like a recall or resharing information that they know. And this is really important for like diagnostic and formative assessments, because you kind of need to know if students know some of the baseline knowledge from previous grade levels before you expand on what you're going to teach them. But the key thing to note here is this is insufficient evidence of proficiency. Essentially, we don't really know if students have learned the material through representation questions. Instead, what we want to challenge them to do is look at sense making. So what is sense making? It's explaining why or how to make sense of a novel phenomena. So essentially giving students a situation they have not previously seen before, and they need to apply what they've already learned to this situation. This is great for summative assessments because this is a way to actually measure that proficiency. And so being able to make sense of novel phenomena is truly at the heart of the NGSS and is truly the goal of the NGSS. So we want to shift our questions to sense making, just like the NJSLA-S has done so as well. So I want to quick point out the performance expectation that previous released test item was actually looking at. So the one about the iron and the rust was looking at MSPS 1-2, and students had to analyze and interpret data on the properties of substances before and after the substance interact to determine if a chemical reaction has occurred. So essentially that idea between like chemical and physical change, and then looking at data that has been collected on those substances to support if that happened or not. And so when we think back to that question here in just a minute, we're going to actually just relook over what those 3 dimensions of the NGSS are in case you need the reminder. So the 3 dimensions of the NGSS, first is the disciplinary core idea, or what we refer to as the DCI. And this is essentially what students know, or like the content that we're giving them. So students understanding that if a substance changes from from the beginning of something and then it changes into something else, that could be evidence of a chemical change. That's content. The science and engineering practice, or called the SEP, is what students are doing. So looking at data, analyzing and interpreting that data in order to yield results. And then the last thing is the cross-cutting concept, or what we call the CCC, which in this case was patterns. So being able to identify patterns throughout observations, through data, to see if there's any connections from there. So when we break down the MSPS 1-2 standard into those 3 different dimensions, and then think back to that previous question about the iron and the rust, students need to incorporate all of these dimensions to answer this question. They need to know about structure and properties of matter. They need to be able to know if something is the same or not based on its properties. They need to analyze and interpret the data that was gathered within that experiment. And then while looking at that data, they need to identify the patterns that are occurring. And they're doing this all with a novel phenomena of iron and rust, making this sense making. So now that we have an idea of what sense making is, Julia is going to talk about some strategies that you can use within the classroom to help get students ready to tackle novel phenomena within their state test.
Thank you so much, Emily. And now that we've talked about what sense making looks like, we're going to review some strategies we could use for test prep across the school year, including using phenomena throughout a whole unit. And now going back to our standard, I know we just saw it, but students have to analyze and interpret data on the properties of substances before and after the substances interact to determine if a chemical reaction has occurred. And we've mentioned using phenomena in assessments, but how can we give students plenty of opportunities to make sense of a phenomena throughout an entire unit? So what are the different types of experiences too that we can give them to practice for those rigorous questions? Let's take a look at how we on InnerOrbit would do that. And for that, we're going to build a roadmap of phenomena. And all this phenomena is on the InnerOrbit website, but we would discuss all of these phenomena throughout this unit. And in the very beginning, we could start with this phenomena discussing how can we tell if a chemical reaction has happened in a super saturated solution. So since we're still in the beginning of the unit, we would consider a lower stakes discussion like a whole class walkthrough. And that is all about how crystals formation may or may not be a sign of a chemical reaction. And we would include discussion questions to target the cross-cutting concept and the SCP for the whole class to answer together. Now, moving on to the middle of the unit, we could talk about why the reason this happens when sugar burns. And all of this is about separating the class in groups to answer questions collaboratively, maybe with a printed scaffolded group phenomena exploration. And students would discuss changing characteristics in sugar when it is burned. And in this stage, mid-unit, students are answering rigorous questions that target the DCI, the cross-cutting concept, and the SCPs, but with scaffolding from the teacher and support from their group. Now, lastly, we could assess students by building a short online assessment to be administered individually, covering this glowing penny and the oxidation reaction that's occurring in this copper penny. So in the final part of the unit, should already be able to engage with rigorous sense-making questions. And teachers can still provide scaffolding as needed, but removing those scaffolds is important for building students' independence and confidence. Now, I do want to highlight that all this phenomena and even more should be available on the InnerOrbit website. For every single performance expectation, we have from 4 to 6 phenomena that you can use throughout the whole unit. And at this point, we do have plenty of phenomena, but maybe our students are not there yet, and they're starting at a level where they need even more phenomena, and they need lower level phenomena in order to access these rigorous performances. Well, there's something we could do for that. And maybe what we would recommend in this situation is for you to go from the on-grade level standard to a prior grade level standard. In this case, we would go back a whole grade level band to this 5th grade standards, where students have to develop a model to describe that matter is made of particles too small to be seen. Now, we would do the same thing. We would build a roadmap with phenomena just from a previous grade level. And we could first discuss how this lift-off is possible. And it's all about how particles of air push up an indoor skydiver, but it is invisible to the naked eye. Then we could go over the reason why sugar in candy seems to disappear when it's left in water, but the colors slowly spread out through the dish. And lastly, we can ask students to explain why this foil boat is able to float on top of a heavy gas. And again, we have plenty more phenomena on InnerOrbit that you can use for this. And this is also for the prior grade level. Now, to sum up, the main takeaway of using phenomena throughout a unit is that first, practice makes perfect. So we should be using phenomena throughout all units, not only during test prep season. And then using different phenomena provides more opportunities for students to model and practice transferring of knowledge and sense making. And if students are struggling with phenomena targeting their grade level band, we can always lower the stakes with a prior grade. And to give further sense making opportunities and identify possible gaps in knowledge or skills from previous grade levels. And that pretty much sums it up. Now, how do we scaffold from representation to sense making? Because we know we're talking in a group setting. This is how we would use phenomena. But really, when we talk about 3-dimensional performance and sense making, at the end of the day is our goal. Our goal is to get students to that rigorous performance where they can use their knowledge through the lens of the cross-cutting concept, using the SCP, and explaining why or how a phenomenon happens. And that's what true mastery looks like. And it's what students need to be prepared for these assessments. But we can expect to get them there overnight. And that's where scaffolding comes in. So how do we support them in building up to this level? First, we would need to identify those invisible steps that we're asking students to take. If we're expecting them to go from simple recall to applying knowledge across dimensions, we have to be intentional about breaking that journey into manageable steps. And then we need to gather data at each step, not just at the end, to understand where students are struggling and adjust our support accordingly. And by focusing on these steps, we're not just preparing students for an assessment, but we're helping them develop the critical thinking and reasoning that will serve them far beyond the NJSLA-S and far beyond the classroom. Now, let's talk about bridging the gap between representation and sense making. And for that, let's look at this example specifically. So in this phenomena, a teacher is placing a clump of iron wool on a scale and then is setting it on fire, as we can see here. So before burning, the iron wool has a mass of 27.3 grams, but after burning, the mass actually increases to 29.1 grams. Now, here we're asking students with a true sense-making question, and this taken from the InnerOrbit website, integrating the DCI, the SCP, and the cross-cutting concept together. And this question is just as rigorous as the one we saw from the NJSLA-S. This is a high-level NGSS-aligned task because students must first make a claim about why the mass is increasing. Then they have to use evidence from the data table to support their claim. And they also have to explain their reasoning using knowledge of chemical reactions and conservation of mass. So this is a fully three-dimensional question. Now, to get them there, we can expect, as I was saying before, we can expect students to jump from representation to sense making. And that's where two-dimensional questions come in. And these act as a bridge between simple recall and full sense making. Some two-dimensional questions combine the DCIs and the cross-cutting concepts, asking students to explain how or why scientific knowledge is applied through a specific lens. And then others combine the DCIs and the SCPs, shifting students from recall to application by having them engage in scientific practices instead of just memorizing facts. So by incorporating more two-dimensional questions in instructions, we're helping students build the skills they need to fully engage in sense making. So this is a stepping stone that makes the shift to mastery feel much more achievable for them. Now let's look at examples on how we would scaffold up to those sense making questions. And we would actually just start with a core content question only. So a DCI only questions. And these, even though they won't represent mastery, they play a crucial role in assessing whether students are ready to start making sense of something novel. So this is a DCI only question. We're intentionally leaving out the cross-cutting concept and the science and engineering practice. Because before students can explain, model, analyze new phenomena, they need to have a solid grasp on the foundational science ideas. And this question checks for that by focusing purely on the DCI. And it also acts as a checkpoint. So if they can correctly answer these types of questions, then they have the necessary foundations to start applying their knowledge in more complex sense-making tasks. Now, moving on to our second type of question, here we're actually combining the DCI and cross-cutting concept, intentionally leaving out the SCP. And this is the type of question that we were talking about before that kind of helps bridge the gap between simple recall and full three-dimensional sense making, because it ensures that students, in this case, can identify patterns in chemical reactions. Then we do the same thing, but now with the science and engineering practice. So we're deliberately combining the DCI and the SCP, leaving out the cross-cutting concept, because we want to assess if students can apply their content knowledge to this science and engineering practice, which in this case is analyzing and interpreting data. Can you analyze and interpret data with what you know about chemical reactions? And this types of question helps us understand where the gaps are and adjust instruction accordingly. So for example, if they were able to meet the performance for other questions, if they were able to answer DCI only questions, if they were able to identify patterns and answer questions that involve the cross-cutting concept, but they struggled with this one, maybe what they need most support could be in analyzing and interpreting data, because they could actually meet the performance of the prior questions. So by designing assessments this way, we can not only strategically scaffold students' thinking, but also gather useful data. And now, looping it back to our three-dimensional question, this question is a true sense-making task because it requires students to engage with all three dimensions. And this is a type of question that best prepares students for the NJSLA-S. So by scaffolding students through representation, then two-dimensional thinking, and finally three-dimensional sense-making, as we see here in this graph. We not only ensure that they're truly developing the skills they need, not just for assessment, but actually for real scientific problem solving. And this is where we want all of our students to be. We want them to be able to answer three-dimensional questions, sense-making questions independently. Breaking down the journey into intentional steps helps us support them and support every single learner in getting to this level of thinking. Now, this is some data that I want to show you because, as you know, we partner with many districts, and even in New Jersey, we do. So this is mainly just showing you a data set from a district that has given assessments across the school year, and this could be your data if you were to give assessments on InnerOrbit. So you can gather all of this data to help you make informed instructional decisions and support students after giving assessments, and also have informed PLC conversations with the rest of your teachers. And now I know this has been a lot, and we have about 3 minutes to spare. So I'm going to kick it back to Emily to wrap us up in this webinar, and I hope this has been fruitful for all of you.
Thank you so much, Julia. I thought it was very fruitful. Thank you very much. All right, so we would love to invite you all after this webinar to follow us on social media if you're interested, at InnerOrbit EDU and then at InnerOrbit NJSS. Our YouTube channel is where you're going to find a ton of information, like webinars like this one, as far as like different test prep strategies go, more information about the NJSS. And you can also email us at inquiries@innerorbit.com if you have any questions or you're curious what InnerOrbit could look like for you in your school or in your classrooms. Or you can just click on this link that Julia is going to drop in the chat again, and you could schedule some time to meet with her. We do free pilots of InnerOrbit. So this is where you and your teachers and your students can have full access to InnerOrbit for 1 to 2 months, and you can really utilize it and see if there's value in it. And right around now is a great time to do a pilot, because you can use InnerOrbit leading up to your state test and see if you can implement some of these test prep strategies before students actually get in and take that test. Thank you so much for joining us today for this webinar. We really appreciate it. And thank you so much.